Purpose of this video is to give you some clues about how to handle the error analysis lab and the math that goes along with it. So you'll go into the lab first, and there's some background. The background is going to be fairly important to answering some of the later questions once you've gotten the math handled. So you should read through this, and I will give you some hints about how to handle these kinds of equations, which really aren't as bad as they first appear when you first look at them. The procedure is here. The idea is that you'll be faced with this situation where you've got this ruler up here, and then you're going to hit start, and then you have to stop it, and it will catch it here. The whole idea is to see if you can catch it around 100 centimeters as read at the top of the clamp here, and I'll show you how that goes in a second. But let's just hit the start button and see what happens. Now it's going to wait a little while before it drops, and that time is going to be random. So let's take a look at what happens when we just look at that. Eventually it's going to drop. There we go, it drops. Now I didn't stop it, so it just fell right through. I have to be quicker than that. Alright, so we'll try it again, reset it. We hit start again. See if I can be better this time. Alright, so it's a little bit better. At least I was able to catch it, although I didn't catch it anywhere near 100. Anyways, that's okay. So what I can do is I can zoom in on this a bit, and I can get a sense of what the measurement is. So I look at this, and you can see that it stopped here. 20, 1, 2, 3, 4, 5, 6, and 7. So my first measurement here would be 27. I go to my lab notes, and I type in trial 1, and that would be 27 centimeters. Oops. And I can do this for all my different trials, and that's what you guys will do as well. You'll go in and you'll put all this information in, so that when you go write your lab report, you'll have the information you need. Alright, so I'm going to zoom out of here again, and we will reset it, and we'll do another trial. There we go. That's much better. I was able to get it here at, looks like 111 centimeters. So that's what I would do. Type in trial 2. 111 centimeters. So just keep on doing that, and I have to do that 20 times. Now I know to do all this because of what the procedure tells me to do. Alright, so that's all you have to do. Just do that 20 times. Write down all the results, and then you'll go to the lab section. So what you'll see when you go to the lab, let me go back here a little bit. You'll see this short answer, and then you'll click on that. I know these are different notes from a previous trial, so don't just ignore that. But you'll see all your notes there with all of your results, and then you can answer the questions. So you'll list the results and you'll put them in these boxes below here. Make sure you use the centimeter unit on each one, and then you can do the data analysis, which means you have to do a little bit of math. Now the math is not that bad. I've got an example here of how to handle the average, for example. Now I know it looks complicated, but this business here, all it means is add everything together. So if you had 5 results, you're going to have 20. But if you had 5, this is how you'd handle it. These are all my results. I add them all together, which is what I've done here. Now I divide by the number of results I have. 1, 2, 3, 4, 5. You have 20, so you'll have 20 down here. But you'll be adding 20 numbers together and coming up with the result and dividing that by 20. I'm going to be adding these 5 together and dividing it by 5. That gives me 106 centimeters. That's the average. So out of all my trials, that's about what I averaged. That would be pretty good if I got that, because that's pretty close to 100. But what I'm interested in also is the spread of my results. I mean, how precise was I? In other words, I mean, are the results close together, or are they kind of far apart? And we get that by looking at the standard deviation. Now this one looks even nastier than the previous one, but again, it's not as bad as it seems. you've got your average here, 106 centimeters, and all you're really doing is taking each of these results here and subtracting the average. That gives you a result that you end up squaring. So in your calculator, you put 96 minus 106 and you get negative 10. And then you hit the x squared button and it squares it and you get 100. So if it's a negative value, it doesn't matter. It's going to come out to be positive anyway. All negative values when you square them will come out to positive values. So we do that for each of these. Just taking the number and taking these numbers here and subtracting out the average, which we calculated up here. So we do that for each of these, and we square each of them, and we come up with these values. Then what we do is we add all of these values together. That's what this sigma here means. It means we just add all of those results together. So it's the x minus the average squared, and we do that for each of them, and we add all of those together. That comes out to be 871. Now the 1 over n minus 1 is the number of trials minus 1, which in this case happens to be 4. So effectively what we have is 871 divided by 4. Remember, the 871 is the addition of all of these different things here. And 871 divided by 4 is 218. We take the square root of that, and that's the root button on your calculator, and that comes out to be about 15. So the 15 represents kind of like the spread of results. And if it's a big number, it means the results are fairly close together. Fairly far apart. If it's a small number, it means the results are fairly close together. So that's really all you need to do for the maths. It's not nearly as bad as it looks with all these funky symbols and things. So going back to the report here, you've also got this percent error. The expected value is 100 centimeters because you're trying to stop it when it gets to 100. The x bar is the average, which we already calculated, and I think you can handle that. If it was 106, just like I calculated, it'd be 106 minus 100 divided by 100, and then you multiply that by 100%. That gives you your percent error. I don't think that's too bad because you've already got the average, so this is a fairly easy one to do. The standard deviation we talked about. And these are the conclusions. So the question you might have is, well, how am I going to answer all these questions? Well, what I recommend you do is go back to the background. The background is at the front here. I recommend you read through that. That's going to have all of the answers to the questions that you'll need. There's a good discussion here on accuracy and precision. It's got some pretty pictures which I think explain accuracy and precision fairly well. And I would recommend that you go ahead and read through this. We've obviously been through the math already, and then you can get a better idea about how to answer some of those other background questions. Alright, so that's pretty much it. Good luck.